Good morning, all of you. We have just gone through the unexpected loss of certain credit assets and the calculation of unexpected losses. And we have already done the calculation of expected losses. It's a linear type of a function where you multiply the PD, LGD, and the exposure. Depending on maturities, we can get the expected losses calculated in that manner. And the expected losses, if you take the portfolio, there you get different assets in the portfolio. The total expected loss of a portfolio can be determined by adding up individual expected losses in the assets in that portfolio. So that is a straightforward exercise. But if you go into the unexpected loss, the calculation of unexpected loss has a rather complicated process. And when you get the total portfolio unexpected loss, you can't just add up and get the total unexpected loss of the portfolio. In order to get the unexpected loss of the portfolio, you have to take into consideration the correlations between the credit assets. And if you know the correlation, you are in a position to get the resultant or the total unexpected loss of the portfolio depending on the number of assets. Now, when we go into the portfolios, you will find the portfolio can have different number of assets. When you have two assets, you have only one correlation. When you have three assets, you will have three correlations. Or we call them the covariances. The meaning of covariance is the two assets vary collectively, or both the things are varying, and the one particular asset's variation has a connection with the other asset's variation. So that is what you call the covariance. And with the covariance, there will be a correlation also. Now, if someone asks, what is the correlation or the difference between correlation and covariance? Now, when you say covariance, it's a concept. It's a variance. Now, if you say assets A and B, A asset has a variance with respect to B. B asset has a variance with respect to A. That is what you call covariance. In other words, how these two assets are behaving. That is what it means. But the correlation is, depending on that relationship, we can measure a normalized coefficient. That is what you call correlation coefficient. Now, this correlation coefficient, the value of the correlation coefficient varies between +1 and -1. But when you say covariance, there's no such limitation. It can be plus or minus, but there's no such limitation. But in the correlation coefficient, there are two end values. The minimum value for correlation coefficient should be -1. The maximum value for correlation coefficient should be +1. So that is the difference. So then I think many people wonder what these two concepts are. Covariance is one concept, correlation is another concept, but both are really originated through the same origin. But correlation coefficient is a more normalized coefficient. But covariance is also talking about the same phenomenon, but it's not normalized. It's a normal type of so it's like this. Now say with respect to one asset, what is the other asset's variation? So that is what it means, the covariance. But when you say correlation, it gives some idea about the relationship. 100% positive, 100% negative, 25% positive, or that type of thing. But you all should understand that when you talk in terms of correlation coefficient, if it is more than 50% only, you consider it as a significant relationship. In order to just show or represent a significant relationship, you should get a value for the correlation coefficient. The value should be higher than 50%, either plus or minus. Then if it is a plus figure, we call it a positive significant relationship. Or if you get a minus figure for that, then you call it negative significant relationship. So these are the normal ideas with regard to these things. We will further just discuss these things today. Now, this one we discussed the calculations up to this and the effect of correlation. Yeah. Now, of course, now when you talk in terms of unexpected losses, so the unexpected loss of a portfolio we have been able to calculate, and the unexpected loss of a individual asset also we have been able to calculate. So I think we did the calculation last time. Now, as per that calculation, we have just arrived at a portfolio unexpected loss. And in the example, I have just explained taking into consideration two loans, how you can arrive at it's a portfolio of two loans, and how you can arrive at the total unexpected loss of the portfolio. But if you have more than two variables, more than two assets in the portfolio, so then accordingly we have to just get the particular formula arranged. Now I will just give you some type of guidance on that today, because there can be several assets in a portfolio. You can't limit that. I think sometimes it can be either 100, 200 or so. So therefore, you can't just limit that number of assets in the portfolio. So what you need to do is you need to see how you can deal with such a number when you get that type of a number. So in order to get a good idea about it, I will just show how you can do it. Now, don't think this as a unnecessary exercise, because what I want to tell you is, now in your organizations, sometimes you might have some software packages to do credit risk management or rating models or whatever, default analysis, that type of things. You might have a software. So there also you can really get an idea how these things being calculated. If you go through these theoretical aspects, Now I will show you when the number of assets increases in a portfolio, how you can deal with that formula. So I think that's a important thing to learn, because even sometimes you might be in a position to see the validity of your software package if you know these things. Right. Now I will just show you on the board these things. Now as it is, ULP, that is the portfolio unexpected loss, is equal to square root of UL1 squared plus UL2 squared plus 2 rho 1 to UL1 into UL2. Now this is the formula. This is the formula. Now this formula is applicable only for two asset portfolio. Two asset portfolio. Now I will show you now. I have put on the board the two asset portfolios unexpected loss, the calculation of two asset portfolios unexpected loss, how we can do the formula I have given, and then I will give you the other one also. Now it is in the on the screen. UL1, how you get the UL1 calculated? AE1 into square root of EDF1 into sigma squared LGD1 plus LGD1 squared into sigma squared EDF1. So that is the calculation of unexpected loss for the individual loan. Now what I want to tell you is, now when you do these things, you can get the individual loans unexpected loss calculated. But to get the portfolio loss calculated, you have to apply the formula. Right. Now, in the application of this formula, right. Now, this particular formula is for two assets. Two assets. If you go into three assets, what could be the formula? Now, I can just show you this way. ULP is equal to square root of UL1 squared plus UL2 squared plus UL3 squared plus 2 rho 1 to UL1 into UL2 plus 2 rho 2 3 UL2 into UL3 plus 2 rho 1 3 UL1 into UL3. Now this is the formula for three asset portfolio. Now just look at it. How do you arrange that? So what you do is you just get the first three assets or three assets, UL1 squared plus UL2 squared plus UL3 squared. So that is the first thing you need to do. Then you get the correlation terms or correlation coefficient, 2 rho 1 2. That is the correlation coefficient between 1 and 2. Then you have to do the multiplication UL1, UL2. Then you get the, then add the other one, that is 2 row 1 row 2, 3. Then you get UL2, UL3. Then you get another one 2, 1, 3. Then UL1, UL3. And you get the totals square root. That would be the portfolio's unexpected loss. I think you can follow that, no? Can you see the board clearly? I think the ink is not that bright. Anyway. Right. Now, I think you can follow the trend. When you have 3 assets, you can put it as UL1, UL2. That all these things will come. The square figures come, square terms come at the beginning. UL1 squared, UL2 squared, UL3 squared. Then you get all the correlation figures, 2 row 1, 2. Then respective UL1 and UL2. Then 2 row 2, 3. UL2, UL3, then 2 row 1, 3, UL1, UL3. So that is how it comes. Now this is for 3 assets. If you go for 4 assets, what will happen? Now what I want to ask is whether you follow this. So I think if you go by the trend or the real methodology or the real arrangement, you will be in a position to construct that formula. Whatever the number of assets, you will be able to just write that formula. Now, I can give you certain other type of support or some methodologies to write down the formula with the number of assets. So I think leave it on. Right now you can see the things clearly. Just to see that. Anything if you just difficult to follow? So I can just put it again. When you have 3 assets, this is the formula. Now I think if you if you write for 4 assets, there's a possibility of writing that. So I think you can try that way. So there you get, if you have 4 assets, you will get UL1 squared plus UL2 squared plus UL3 squared plus UL4 squared plus 2 row 1 2. Likewise, you have to just get the arrangement. You should have row 1 2 figure, then you need to have row 2 3 figure, then you need to have row 3 4 figure. Again you have row 1 3 figure and row 1 4 figure. So then altogether there will be, when you have 4 assets, there will be how many covariance terms? When you have 4, you might have 6 covariance terms. When you have 4 assets, 6 covariance terms. So that is another way. There's another way to check how many covariance figures contained in the formula. So that is, there's a formula called n into n minus 1 divided by 2. So if you apply that formula, you will be in a position to find the number of covariance terms included in that formula. Now, if I ask you this question, say you have 10 assets. When you have 10 assets, how many covariance terms there in the formula? Can you calculate and tell me? When the portfolio has 10 assets, how many covariance terms would be there in the formula when you have 10 assets? Yes. Yes, you have to just write something or just send some message. Yes, Sumudhu, correct. Muresha, correct. Right. I think the formula is, you have a very direct formula, that is n into n minus 1 divided by 2. So in case of when the asset number is 10, n becomes 10, then 10 into 9 divided by 2. So then 5 into 9 would be the answer, that is 45. So then there's no issue. But you might have an issue to just get the rows, row 1, 2, row 2, 3, likewise, there's a particular issue. So what you need to do is, now that issue also can be get rid of by having this type of, now there's a thing called variance covariance matrix. Variance covariance matrix. If you have that matrix, then it is very clear for you to select the covariance figures. I will show you what it is. I will show you what it is. Now, when you have, say, 5 assets, now you have to just get the variance covariance matrix. 5 assets. You say row, this is row 1 1. Row, you can say it is the square. Then you have Now you just look at it. Now you have a diagonal here. Now this represents variance. This represents variance. So you have to get these figures. Now I am referring to a 5 asset portfolio. 5 asset portfolio. So how many correlation figures are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 5 assets, you will have 10 covariance figures. 10 covariance figures. Now the figures are there. So then you can write it. Row 2, 1, row 3, 1, row 3, 2, row 4, 1, row 4, 2, row 4, 3, row 4, 5. Sorry. Row 4, 3, then row 5, 1, row 5, 2, row 5, 3, and row 5, 4. Those are the figures. Have you got the methodology now? Now, I just want you to follow that matrix. Now, when you follow that matrix, you will be in a position to get the covariance terms. Now, I have just demonstrated a 5 asset portfolio. How should you get the covariance terms? Now, as it is, you just look at it. You get row 2, 1 as the first covariance term. Then you get row 3, 1 and row 3, 2. Then row 4, 1, 4, 2 and 4, 3. Then row 5, 1, 5, 2, 5, 3 and 5, 4. Now, if you count it, there will be 10 covariance terms. How many assets? 5 assets. Then now you apply the formula and see whether it is correct. Yes, 5 into 4 divided by 2, that is 10. 20 divided by 2 is 10. And the figures can be determined by that matrix. Now, are you comfortable? Are you in a position to apply that? Yes. Anything you need to clarify? Yes, Suresha. Because this will give you a practical tool, a really practical tool you will get.
So, sir, this combination, this matrix also give the number of combination, no?
Yeah.
Yeah, the same thing we are deriving from the formula.
Yes, of course. Because it's a ready type of formula. Because you should not. I mean, you should not worry, or you should not get a burden of thinking about it. So you can directly get it from there. That is why I have just put it.
So but for the organizations, they have to like come up with some software or anything.
Yeah, of course, yes. Software should be there, but only thing is now, if you, even though you have a software, if you do not know what is the concept, really work the things out, you don't have any idea, no. So therefore, if you know that this is the way it is being done, then you can check the things, and you can check the validity of that formulas also, the validity of that software also you can do. So that is why I just give these things, because you can see the validity of your formulas or the software by applying these things. But only problem is now, I think you should ask that question. Now, how are we would it be able to get the correlations calculated of these loans? Now, say you have 2-3 loans. If you have 3 loans, you will have 3 covariance figures, no? So the first thing we need to ask is whether you are in a position to get that correlation coefficient calculated for these loans. That is the first thing you need to ask. So what do you say? Now, these are very practical type of things. Since now Uresha is really asking that type of questions, I'm really happy about it, because you need to understand how you can apply these things in the real life rather than going to the book. Yes, Suresh. Now, what do you think? Are we in a position to get these correlations calculated?
That also should be done from a software, because if we
Yeah,
can.
but even with the software, if you need to do it, you need to have uh, the the relevant data. No,
Yes.
if you do not have relevant data, you are not in a position. Even with the software, it is not possible to do that. So then you need to understand what is the software you are going to use. So what is the methodology? So I can just give you a small hint for that. Now, say for example, if you granted these loans to a certain quoted company in the stock exchange, we are in a position to see their correlations through the stock market. Because through the stock market figures, we are in a position to calculate the correlation between these two entities. For example, say you have granted a loan to John Keels and another loan to say Abans Finance, whatever. Now, if both are finance companies, then what you can do is you can just get uh, the returns calculated through the stock exchange. The other one also you can do that. Then you can just calculate the correlation coefficient between these two. So it's a simple case. Now, likewise, you can have several companies selected and get the correlations with each other calculated through the stock market. That is one way of doing it. Even the software can be used to do that. Using a software, you can do that. Otherwise, it's a laborious exercise. Resha, are you okay with that? But provided that you have granted loans to the quoted companies. If that is the case, there's no issue, no? What do you say? Yes, Suresh, you got it? Or
Yes, sir. Just I can't remember whether standard deviations and other things are published in the SEC website. I can remember the beta values have been given.
yeah, beta value is there. Beta value is there, but standard deviations and all those things are not being published. But you can calculate it through the returns.
Okay.
The returns are there, no? Because in the stock market, the returns are readily available.
Yes.
So with the returns, you are in a position to calculate the standard deviations
Okay.
and the correlations also. So then, no, that is also now. If you are personally going to do it, it would be a laborious exercise. But what I suggest is, if you can use a software for that, it's not a matter. It's a easy thing to do, because you need to get the necessary data only. So data can be fed into the computer, and you can get the figures, the correlation figures. But now just suggest something to deal with loans, whether those loans, those companies might not be quoted. If that is the case, for unquoted companies, what are you going to do? For unquoted companies, what type of a step you should take for unquoted type of companies?
Consider the existing data with the
Yeah,
bank.
of course, yes. There's a way of doing, because you can just go through some 5-year or 10-year data, and you can get the average return or whatever. And for if you take two companies into consideration, you can do it for the both companies and just calculate the standard deviations and the correlations. That is also possible, no? That is also possible now if you have got the data. So it's a matter of putting this data into the computer. Now you get my point. So therefore, this is not an impossible thing. You can do it. So then we will see how the things can be uh, sorted out. Right. Now, when you go into the risk, diversifiable and undiversifiable risk. Now I think this we have already talked about. The effect of correlation between bank assets is critical to measuring the potential portfolio loss. Intuitively, as the correlation between assets increases, the bank suffers from concentration risk. So that means now the real phenomenon here is default on one asset spills over to other assets, exacerbating the problem. So that is what happens when the correlations are there. Strong correlation is there, it will happen. It is therefore important to have reliable estimates of default correlations. Now, whatever it is, now say for example, we just see the correlation through the returns. The same correlations can be applied into defaults also. Then it would be taken as the default correlation. Now, then just look at this. Now, those things are, I can just tell you, I can just give you the simple principles come in here. Now, when you read it, when defaults are not normally distributed, the zero correlation does not imply defaults are independent. So sometimes you can see correlations are zero, but that doesn't mean defaults are independent. The case here is defaults are not normally distributed. But when defaults are normally distributed and correlation, there's no correlation at all, then we can say defaults are independent. And at the same time, the correlation is not a good measure of dependence when the underlying variables have distributions that are with infinite variance. To overcome the above issue, a function called Copula is defined, which joins a multivariate distribution function to a collection of univariate marginal distribution function. Now, anyway, now I think these things are a little complicated, but what I suggest is, in this particular presentation, I suggested to apply something on certain conditions, but don't worry about the theory part of it. Now, I think up to now, the portfolio loss calculation, the unexpected loss of the portfolio calculation, I think you should not have any confusion, because it is clear. It is very, it is a direct type of an application. So therefore, there won't be any type of a confusion up to now. But these things, the limitations of correlation and all those things are little complicated. So therefore, you should not worry about it. But what I want to tell you is, you have to understand these concepts. Now, in most of the cases, when we apply the formulas, we have an assumption that the defaults are distributed normally. That is the normal assumption. But in some cases, if these defaults are not normally distributed, there are some instances where the defaults are not normally distributed. In such cases, these assumptions will not be valid. That is the only thing you need to understand. You can make a note. So all other things are not necessary for you. Don't just put all these things in your mind and have a confusion. So but my advice is to see that on this particular slide, what you need to understand is all these things we apply on the assumption that defaults are normally distributed. So that is the only thing you need to understand. Right. So in order to get away, or in order to come out from that issue, there's a model which has been introduced. We call it Gaussian Copula model. Gaussian Copula model. Unexpected loss of a portfolio can be estimated by quantifying the unexpected loss of each asset and arriving at the joint probability distribution. Let the unexpected loss of ith asset of the portfolio is given by following relationship. Right. Now here, it's a formula, and we call it Gaussian Copula model. Now in this Copula model, the normal distribution assumption is not there. That is why the Gaussian Copula model is taken into consideration. Right. I think to be simple, what I want to tell you is, we have done several things now. No, we have done portfolio risk calculation of a loan portfolio, and that risk is the unexpected loss. Actually, we calculated the expected loss at the beginning, then we calculated unexpected loss of each loan and unexpected loss of a portfolio that we have already calculated. But in order to calculate that, we have to arrive at the correlations of each asset. And the dependency and non-dependency relied on those correlations. But that is true only when the defaults are distributed normally. So then that is a type of a restriction. So we can't say every time the defaults are distributed in a normal distribution. So therefore, innovation was made, and a model was introduced to deal with assets in a portfolio where these assets are not normally, the defaults of those assets are not normally distributed. So this model is known as Gaussian Copula model. Now that is the formula is given here. UI, it is the unexpected loss of ith asset, is given as AIF. AI is the correlation between two assets, plus square root of 1 minus AI squared into ZI. ZI is the idiosyncratic factor. Idiosyncratic means non-systematic risk of the asset, and F is the common systematic risk factor. Common systematic risk factor means just like beta. And there's another model called Vashisek Model. It provides an easily implemented way to derive the default PDF of the portfolio given the correlation between assets and the expected default rate. Right. Now, with this model, there's another model called Vashisek Model. And now you just go through this, but you should not worry about these models and all, because if this is given for a question, these models will be provided. These models will be provided. But you need to understand what these codes are or notations. You have to be familiar with the notations. That's not the only thing you need to have. So therefore, you just be familiar with these notations. In this model, PD is the probability of default. So it is n minus 1 means now you have to get the EDR. EDR is the expected default rate. psi PD is the cumulative probability function of probability of default. Then rho is the correlation between assets. Where rho is the asset correlation parameter, psi PD is the cumulative probability function for EDR. And n and n minus 1 are defined, where nd is the cumulative probability distribution for a standard normal variable with mean 0 and standard deviation 1. And n minus 1d as the random variable relevant to the area covered under cumulative probability distribution. Now, n, when you put that figure, put that letter n, that means now when I say n something, you have to get that particular thing and you apply it to the normal curve table and get the value. So that is what you call n. We have done it earlier. With the normal curve tables, we have done it. Now say for example, if you, I will just do an example of this nature, and I will do an example, and with the example you will be able to understand. To see how this works, assume that rho is set at 15% and the PD of the portfolio is also 15%. If psi PD is equal to 10%, the value of PD is then 4.82%. Now this psi PD is not the probability of default, it's a cumulative probability function of probability of default. So then you should not confuse, or you should not mix these two things. This PD is completely out from this. This is separate. This is a separate concept. Right. I think you have this normal curve table, no? Shall we get it? Normal curve tables ටික දාන්න දැම්ම නම් හොඳයි. එවන්න පුළුවන්. හරි. Now, you should focus your attention to this formula and be familiar with the wordings here, notations here. Now, when you have a notation like this, n, capital N, and within a certain brackets, you get some other figures. So the meaning is you have to get all these values and do the calculation, get an answer, the result. That results, you have to get the normal curve table readings. Right. Now this one. Now I will show the application of figures here. PD, it is the probability of default. of a portfolio can be taken as this n. N is the normal curve figure within brackets n minus 1 EDR plus square root of rho n minus 1 psi PD divided by 1 minus rho square root. So I will just explain this with the figures. Now rho is the asset correlation parameter. It's a parameter. Now I think you need to think we are not going to get correlations between each assets, but we have taken a common factor for rho. It's a parameter. Then psi PD is the cumulative probability function for expected default rate. Expected default rate is distributed in a cumulative probability function. That function is taken as psi PD. And n minus 1 are defined where nd is the cumulative probability distribution for a standard deviation, normal variable with mean 0 and standard deviation 1. So I will just show you these things in this manner to get the better understanding. I will now explain these things on the board. Right. Now I will show what this thing is normally represents. When I say n 1.23, so what is that? So that is, we have to go through the normal curve table and get this value. So how are we going to do it? Now just go to the normal curve table. Now we are going to get the value of n 1.23. Now I will show you how you can get n 1.23. Now you have to get this normal curve table, right? You have to get this normal curve table. Now here you get minus figures. Right, now you should get the positive figures. 1.23. Now 1.2 comes here. 1.2 comes here. 1.23 is here. Then the answer is 0.89065. 0.89065. So this is the answer for that. Now these are really the Z figures. So the particular figure is given here. So then n 1.23 is this amount. Now I will give you another one. Now say if I get a value like this, say n 1. Right. Now what you need to do is just right now I have just put on the board another value n 2.348. Can you get the value for that using the normal curve table? Can you get the value for that? N 2.348. I just want to give you a good guidance with regard to the using of normal curve tables, applying the formula and all that. So therefore, I just give you the skill of getting these values from the normal curve table, right? First of all. So now what you need to do is you just see what is n 2.348 by using the normal curve table. Just use the normal curve table. Yes. Can you get the value for that? 2.348. Now do this exercise. Now what I need you to do is you just do these exercises and then you get the skill of doing these things, and when the problem solving comes, this will be very helpful for you. Yes. Just give the value. But only thing is this has 3 decimals, but here it deals with only 2 decimals. 2.348. So then you need to have some type of a small thinking for that. It is now what you need to think is it is in between 2.340 and 35. So since it is 348, it is in between. It is more close to 2.345. More close. Yes. Yes, Suresha. Amidu, Sumudu. Because what I need you to do is just get familiar with this normal curve and all that, the readings and all. Just to give the value of that in 2.348.
0.99030.
Yeah, it's like this 2.348. 2.34 you can go. This is the 34 value 0.99036. But there's another value that is 2.335, not 48. So it is, so then the value should be little less than that. So how can we apply that? How can we arrive at that? So that's the question. So we can have the difference between these two. That can be divided. I mean, how this is 48, no? So then it is 48 over 50. What we have to do is we have to add to this value. Now you have to get this difference and 48 over 50 percent, 48 over 50 should be taken here. So that is the portion. Now, first of all, what you need to do is you need to get the difference between these two places. Now, this represents 2.340. This represents 2.35, right? But our required value is 2.348, right? So then what we need to do is we need to see the difference between these two. So what is the gap between 2.34 and 2.35? We'll see the gap. The gap comes as 0.99061 minus 0.99 036. That comes as 0.00025 into 48 divided by 50. Yes. Now, Uresha, what did you get? 0.9933.
0.990. So what I did was I got the difference and
Yeah.
then I divided, because between these two values there's only 0.01 difference. So I
Yeah.
divided by that and then did this what you call it into this
Yeah.
the missing amount.
Ah.
So I think there's a difference coming from that.
No, now what we need to do is this. Now you get two figures. No, now for 2.34 you get a figure 0.99036. Is it?
Yes.
Then you get another figure for 2.35. Is it?
Yes.
0.99061. But our required figure is 2.348. It is
Yes.
little less than 2.35. No. So then what we need to do is what I did was, now we can get the difference between 0.99061 and 0.99036. That comes as 0.00025, right?
Yes.
0.00025, 0.00025. And you have to calculate the portion. The portion is 48 over 50. 48 over 50. Now, why I say that? Because or we can say not 48 or 50. Yeah, 48 or 50, because the thing is now this 0.00025 represents point 10 difference, no?
Yes.
0.10 difference. Sorry, 0.10
Point
difference.
zero.
Yeah, 0.10 difference. That 0.10, yeah, you have to have 0.48. No, we have to see what is the portion we are taking here. What is the portion of 0.0025 to be taken? So there we can say 8, 48 is But what I feel is now here, now these two things, these two figures actually 0.99036 and 0.99061 represents 0.10 difference. Yes, correct. 0.10 difference. 0.10 difference to be divided, no?
So is it 0.10 or 0.01?
0.01, sorry, 0.01, yes, 0.01 difference. 0.01 difference, that has to be 0.01 difference is distributed in 0.00025 value, right? So then we have to see 0.01. 0.008. We have to see what is 0.008.
Then it's point,
Yeah,
the value is
yeah, 0.008. 0.008. So then you have a 0.0002 value. So that value has to be added to 0.99036. You get that value 0.99056.
Yes, sir.
Right, correct. 0.99056. Right. So this is how the n values are taken, but only issue is if you have more than 2 decimals, you will have to face this issue. So if you want to just get rid of that issue also, what you can do is you can round it off to 2 decimals. Then this issue will not arise. Uresha, can you say that? Now when you get it as 2.35, then there's no issue, no?
Yes, sir.
And just
Then
get it directly from the table, no issue. But you can I think you can use your discretion there. So if you feel that it is a problematic case, what you can do is you can the n value can be rounded to a 2 decimal value. 2 decimal value. Now if you round it off to a 2 decimal value, then it is there's no issue. You can just get it from the table directly. Otherwise you have to do this type of a calculation, and it is little cumbersome, right? Now I just want to tell you the other way. Now this is what you now did was n something. Now if you get a value like this, I will show it on the board. Right, now you look at it. N minus 1, that is N inverse. We call it N inverse. N inverse 0.8906. So then what we need to do here is, you need to go to the normal curve table, and not that way we need to do. We should go to the body of it, not the edge column. You have to find this value within the numbers. So you have to find this number somewhere in the normal curve table. You just go to the table now. This is the value is 0.8906. Now we are not going to get the n 0.8906. Now we are going to get the n inverse 0.8906. Right? Now just look at the value. Now just look at, you can just go through this normal curve table and find out this figure on the table, not on the edge of the column or whatever. So 0.8906. All are here 0.99 something. Should be somewhere here, 0.8906. Here you get 0.89065. It is not 0.8906. It is 0.89065. But if you take the other one, closest other one, 0.88877. 0.88877. So now you can check when you want to get 0.89060. What is the value we have to take for that? Some additional value to be taken here. So that we can take by looking at this. Now just look at it. Now our value is 0.89. Our value is 0.89060. 0.89060 minus 0.88877. So there's a difference of 0.00183. 0.00183. So we can just say, so then what is the value? It is 1.228 like. 1.228 like. Now just look at it. Now if you go to this 0.89065, it would be 1.23. Yeah, 1.23. But it is not the case. It should come somewhere here, no? You can see the mark here, somewhere here. So then it is close to 3, but 1.23, it is close to 1.23, but there's a small difference. So therefore we can say 1.228. 1.228 can be a better fit. Do you agree with me? Uresha?
So we have to take the difference. That is, it comes to 0.00188.
Yeah.
Then don't we have to divide that difference by?
Yeah, no, that's correct. That's correct. No, what I want to tell you is now, this is correct. We should not take that much of a, even we can do that, no issue. And what you say is the difference between, 0.02 and 0.03, it is how much?
But point 0.00188.
0.00188.
Then it divided by the
Yeah,
0.01, which comes to 0.188. Then we have to get that value,
yeah,
1.23 minus 0.188.
yeah, right, correct. Yeah.
Is it correct, sir? The way
No, no, it should not be 0.188. That is wrong.
okay,
Because now it's a big value, no, 0.188 means a big value. So
yeah,
but we should not, I think the issue here is, now by dividing 0.01, I think we made the mistake if you do that. So what we need to do is, now here you have, say, instead of 8906 you have 89065, no, that is the
yes,
issue. So
yes,
then we can say it is very close to this, but it is not 3. It is very close to 3. So that means we can say 1.228. 1.228. 8 is the next thing, no. 9 is also possible, but if you want to get it accurately, there's a way of doing it. Now say this 0.01 difference represented by, you can see, that is 0.89065 minus 0.88877.
yes.
0.88877. So that difference is 0.00188, right? So that really represents 0.01, right?
Yes.
But we are not going to see now 0.00188. So then, mm, 01. So we have to see what is this amount now. Now our difference is what? Our difference in the sense, now from, say, from 88877 to 0.89065. So what is that amount? So that is how we can get it. So 65. Then it is not 583. That should be 183, no? 0.00183 would be there, no? So what we need to do is, we have to divide this with, or now say if you take, now our figure is 0.8906,
Yes.
right? 0.8906. Now from 0.88877 to 0.8906, the value is 0.00183. 0.00183. You agree with me? 0.00183, is it? So then we have to see what is the portion of 0.00183 from 0.00188. That is what you need to check, right? Then we have to multiply it with 0.01. Then you get the figure.
So how did you get this 183?
No, 183 is, now that 183 is the value from 0.88877 to 0.8906. That is our figure, no?
Yes.
So that value is 0.00183. Do you agree with me? Now you can just check and see. Now you check whether 0.89065 minus 0.88, sorry, not 65, 0.8906 minus 0.88877.
Yes.
Just do it. So what is the value there?
That is 0.00188 point.
One, not double A. I need you to deduct, not from 0.8906, not from 0.89065. You have to deduct it from 0.8906, because that is our value, no?
Right. Got it, sir.
Right. 0.8906 minus that 0.88877. So what is that figure?
Yeah. So how much we are missing not to arrive the figure?
That's the thing. There, what is the figure you get?
That is
00183.
Yes.
Right. Now what we need to do is, we need to divide 0.00183 by 0.00188, right? And multiply it with 0.01.
Okay.
Then you get the figure. Then you get the figure to be added to 0.02, added to 2. Right, we will do that and see. 0.00183 divided by 0.00188. That comes as 0.97 something. We have to multiply it with 0.01. And it comes as 0.009. Yes, 0.009. And it is 1.29. That will be the answer. 1.229. That is the answer. 1.229. So because this figure to be added there. Now it's like this, no? Now if you take 0.8887 as the figure, then you get 1.22. Is it? 1.22 plus this. Then what is the figure then? 1.229, is it? If you add just 1.22 here, you get 1.229 as the figure. That is the figure. Urisha, is it okay?
Yes, sir. Definitely, it should be a closer figure to
Very close,
1.23.
very close. Yes, that's the thing. That's the thing. 1.229. I think it is very close to 1.23, no? That is what it means. Very close to 1.23. Because now our because it comes as 0.89065, whereas our figure is 0.8906. That is the issue, no? So then it is a little before that. So that means 1.229. 97 even, we can put that way or even. So accurate. It is so accurate. Is that okay, Uesha?
Yes, sir.
No, what I did, I will just summarize it. It's like this. Now what we do is, now our figure, the specific figure is 0.8906. We have to get the inverse value of normal curve from that. But unfortunately, we have a figure here 0.89065, is it? Then what we first do is, we just see the difference between 0.88877 and 0.89065. That comes to 0.00188. You follow that? Right? So that particular difference is distributed in 0.01 value. Is it? Now what we do is, we just took our value as 0.8906 and we check the difference with 0.88877. That difference comes as 0.00183. Now what we did was, 0.00183 to be divided by 0.00188, and it has to be multiplied with 0.01. Now after multiplication, you get 0.00973. Have you followed that, Suresha?
Yes, sir. I'm okay.
Right, okay. Now I think this is a clear-cut thing. Now there's no issue. Now we go to the formula, right? Now we go to the formula, because I just want you to follow this normal curve readings and all. I think it's very, very important, because you have to do it accurately. In order to do it accurately, you have to do all these calculations. Otherwise, there's another way, and what you can do is, you can restrict your figures to 2 decimals. Then you don't have to face any issue. But in an inverse thing, we can't do that. Inverse thing, you can't do that, because inverse thing, you may not get the exact figure on the table. So therefore, you have to undergo this burden there also. Right. Now we will go to the Vashisek model. Now just look at the figure. Right. Now here the PD means the PD of the portfolio. because in order to assess the portfolio risk, you need to get the PD calculated. Then you have n of n minus 1 EDR. EDR is the expected default rate. Expected default rate plus square root of rho, that is the correlation. N minus 1 psi PD. Now psi PD means this is nothing to do with this PD. It is the cumulative probability function of default, right? Then it is to be divided by 1 minus rho square root. Now we will go to the problem. To see how this works, assume that rho is set as 15% and the PD of the portfolio is also 15%. And psi PD is equal to 10%. Right. Now, this is a direct substitution. Don't worry. This is a direct, very direct substitution. Very direct substitution. Now, just look at it. Now, see. When you go to the formula, you find that n minus 1, that is n inverse, EDR. EDR is the expected default rate. Now, as per the problem, the expected default rate is, that is PD, is 15%. So that is why we put it as 0.15 here. N to the power minus 1, 0.15. Plus, then the rho is set. Rho is the square, correlation that set at 15%. So therefore, square root of 0.15. Then you get n minus 1. Psi PD is equal to 10%. So therefore, you put 0.10 here. Then divided by the square root of 1 minus 0.15. Square root of 1 minus rho, no? So 1 minus 0.15. Then you check n minus 1, 0.15. So now you have to check with the normal curve table. You have to check with the normal curve table, 0.15. Just see whether it is correct. 0.15. You might not get it on the table, but we will see. 0.15. It might be a minus 1. 0.15. 0.15. So you have 0.14917 here, right? .149 is here, but we need to get 0.15. So we need to check the difference. But what is the next available one? 0.15151. There, what is the difference? There also you have 0.01 difference. Yeah, 0.01 difference. Just do the calculation and see. Now our value is 0.15. So 0.15 means 0.15000. But we have a value here 0.14917 and 0.15151. So we can see the difference, right? Say the other way. 0.14917. Yes. 0.15151 minus 0.14917. 0.00234. That is the difference. 00234. 00234. But then you get this. 15. 15. Three. One 1.0364, no? Comes as that. 1.0364. Yeah, 1.036. Is that okay? Is that okay? Puresha?
Yes, sir.
Right. Then you get square root of 0.15, that is square root of 0.15 is 0.387. Then again you get into the power minus 0.10. That also you have to check from the normal curve table. 0.10. 0.10. Here you get 0.10027, 0.09853. So I think that of course you can just take this as 0.10. No, it's a very, very small distance. So therefore you can get it as is that 0.08. It is -0.10. Minus 1.28, like 28. Yeah, 1.283. Took it as that 1.283. Then just square root of 1 minus 0.5, that is 1 minus 0.5 is 0.85, the square root, that is 0.92195. 0.22 naught, yes. You can put it as 0.922 naught, that's correct. And when you do the internal calculation, so the whole thing can be calculated and you get n minus 1.66. 1.66 after these calculations. N minus 1.66. So then now again we can just get this value from the normal curve table again. 1.66. Is it minus or plus? Minus, no? So since it is minus, minus 1.16, no? 1.66. minus 1.66. 1, 2, 3, 4, 5, 6, 7. 0.04846. That is the value. 0.04846, and that comes to 4.84, like, or 85. 4.8485. 4.85. I think it is clear enough, no? Don't worry about all these jargon, right? That is my request for all of you. Don't worry with these jargons or whatever, but it is, necessary burden you need to take. But when you do that, afterwards you will find that there's nothing serious. There's nothing serious, but it looks like serious. Yes, others also should follow this. Huh? Now, what do you say now? Is it okay? You need to get yourself familiar with these normal curve readings and all that, the calculations, the models and all, and the fundamentals, the basics of these things. Now, this equation or the formula being derived with Vashisek model. It's a model introduced and innovated by a person called Vashisek. He was a credit analyst, well-known credit analyst. Right. Now we will see how we can arrive at a worst case default rate of a portfolio. What does that mean? I think in credit analysis, this would be a very much important factor, because you all know there's a particular process called stress testing. In a stress testing scenario, we simulate a particular stress, a plausible type of a stress into your portfolios, and see what could be the result, that type of a stress. Now, with the stress, if our liquidity, the capital adequacy, the profitability and all would fall beyond your regulatory requirements or your targets, then you need to see what would be the deviation if that type of stress happens. In such a situation, is worst case default rate of a portfolio to be ascertained in order to see the impact of the stress. Now we can use this Vashisek model for this worst case default rate determination of a portfolio. I think this is a highly important factor with regard to a portfolio, and in preparation for a stress test situation or stress testing situation, because stress testing is a regulatory requirement for a bank. So therefore, the banks will have to arrange themselves to comply with those regulations. And in that scenario, in order to have this stress testing done, bank should have a methodology to arrive at the worst case default rate at a stress scenario, at a stress situation. WCDR-TX, we call it X percentile of the default rate distribution during a period of length T. A period of length T means in order to arrive at the worst case default rate, we have to assume, or we have to consider a term period, particular period. So that, of course, can be 1 year, 2 years, or whatever it is. The Vashisek model relates WCDR-TX to the probability of default, PD, and a parameter rho describing credit correlation. And really the assumption is in a portfolio, in a worst case situation, all the loans in a portfolio will have a same correlation. So that is what the worst case, that is how the worst case is defined. The worst case is defined as a situation where the correlation among all the loans will become same, and the figure is considered as rho for each and every correlation. Though we have 100 loans, 1000 loans, whatever, all these correlation terms will become the same in a worst case scenario. That is the assumption. So that is why we call it worst case default rate of a portfolio. Right. We will see a type of problem comes here. For an individual loan, if EAD is the exposure at default and LGD is the loss given default, the X percentile of the loss distribution is right. Now, what do you mean by X percentile? X percentile means at a 99% confidence level also, what is the probability? So that is what you call the X percentile of the loss distribution. There you get the, this is the probability of default. Now, if we can calculate this worst case default rate for a particular loan, so you can get the loss distribution as WCDR-TX into EAD into LGD. If you have a large portfolio of N loans where each loan is a small part of the total portfolio, the X percentile of the loss distribution is approximately all the loans to be taken into consideration and get the summation. And that equation is taken as B. Provided there is a single row where WCDR, TX, EADI, and LGDI are the values of WCDR, EAD, and LGD for the ith loan in the portfolio. Regulatory capital for the bank on account of the portfolio is set equal to the expression denoted as B, with T equal to 1 year and X equal to 99.9. So now we call this the credit value at risk, and this percentile is 99.9%. If the horizon is greater than 1 year, the expression B has to be multiplied with maturity adjustment MAI. When Vashisek model is used to determine the economic capital, banks can have their own estimates for rho, and rho for two company loans should be approximately equal to the correlation between the returns of the assets of the companies. Roughly, this is the same as the correlation between the returns of their equities. So that's what I think at the beginning I told you. If you have an issue on getting the correlation calculated, we can get it roughly as the correlation between the returns of their equities. So that's what I just told in the very beginning today. So that is also another factor we need to consider. When worst case default rate for the portfolio is calculated, it is assumed that the correlation between any pair of companies in the portfolio is a value in the range of 0.5 to 1. Higher the correlation, more severe the economic downturn. In normal economic conditions, PD of each loan is similar, and it can be considered as the portfolio PD, and the value is close to zero. Now just look at the sum given in the on the board. I will read it for you. I read it for you. Suppose that the bank has a total of $10 million of small exposures of a certain type. The 1 year probability of default is 1% and the recovery rate averages 40%. Estimate the 99.5% 1 year credit VAR using Vashisek model if the correlation is 0.2. Now, the application of Vashisek model is necessary for this, and just try to get some idea about this. Can you clearly read it? Inosika, can you read it? Shall I read it for you? Uresha?
I can read it, sir.
Can you read? All right. Okay. So I will just give you a break and we'll start by 10:50. So in the meantime, you can just read it and get some idea. I will discuss about it. We will see how we can work it out. Now, before going into detailed things, we need to get some superficial idea about this. Suppose that a bank has a total of $10 million of small exposures of a certain type. So here there are a number of exposures. In total, it is 10 million. The 1 year probability of default is 1%. And now when you say the one year probability of default means in the portfolio. So then what is it? It is the EDR. It is the EDR. Expected default rate is taken as PD. And the recovery rate averages 40%. Now when you say recovery rate is 40%, the LGD is 60%. Estimate the 99.5% 1 year credit VAR using Vashisek model if the correlation is 0.2. Now, by looking at this problem, we have to identify the Vashisek model values here. Now, I just want you to see what are the Vashisek model values we can take here. Now, when I say 99.5% confidence level, or when you say value at risk, or credit value at risk, at a 99.5% confidence level, we call it. So that confidence level comes with the total probabilities. So therefore, in the Vashisek model, there's a notation called X. X comes to this. X comes to this. So then I will put the Vashisek model's values here, and the representation of the Vashisek model by the values. And I look at the problem and I just get the values for the Vashisek model. Now in that case, I just told you EDR is equivalent to 1%. The default rate is 1%. Now this is the particular sum or the particular problem talks about the probability, the portfolio. So then I will say X is equal to 99.5. EDR is equal to 1%, that is 0.01. Then the correlation rho is equal to 0.2. Rho is equal to 0.2. Anything else? Now I think the psi PD or something like is there. That psi PD is none other than 99.5x. So you can just check it with the yeah. Now when you do this worst case default rate calculation, here the cumulative probability function is also taken as the same x. Now you just look at it. So then the x means the 99.5 here. Right. Now I have written down there the value of EDR, value of x, value of rho. So then you will be in a position to calculate the worst case default rate of the portfolio by using this equation, using this formula. So with the values, can you just do it now? Are you okay with this? Now I have given a problem on the board, and as per the problem, I have just written down the values. EDR is given there, it is 1%. X is given there, it is 99.5. And rho is also given. So then we are in a position to calculate worst case default rate for this portfolio. First of all, we will do that. We will do that. Right, shall we start doing it? Yes, Sumudu, Uresha, others also should engage with this. Now it is clearly mentioned here. The Vashisek model values can be taken from this sum, and you can substitute the values into the model. Then you can start doing it. First of all, we get the worst case default rate calculated, the worst case default rate of the portfolio. But the default rate is given, expected default rate is given, that is, it is given as probability of default of the portfolio, that is 1%. But we need to find not the probability of default, but the worst case probability of default or worst case default rate. For that, the sum given the correlation coefficient rho, and we can get the x also. Now we get the worst case default rate by getting 99.5% confidence level. But if the confidence level has to be raised to 99.9%, that also we can do. First, we will get it through the 99.5% confidence level, or even if we want, we can put it as 99% confidence level. That is also possible. But for the time being, we will we will go as the problem's specifications. Anything you need to clarify on this? Yes? Anything you need to clarify? No, with the clarifications, I think you can learn a lot. Don't keep quiet and you just ask questions. Then only you can learn things. And just think about it, and you will see that these things are very important when you go into the credit risk management. And in time to come also, the credit risk management will have a big role to play, even in accounting terms. Now this IFRS 9 and all, they have a bigger focus on probability of default, because they need to get the expected loss calculated, expected credit loss calculated for the current portfolio also. They put it as current expected loss for 1 year, and even sometimes they go for second stage things also. Anyway, Sumudu, Uresha, all can just now start with doing this particular sum. X is 99.5, EDR is 0.01, and rho is 0.02. Oh no, 0.2. It is 0.2. It's 0.2. Now you can apply it on the Vashisek model. It is n of n minus 1 0.01 plus, what is it, the next one. Then go to the formula. Rho into n minus 1 99.5 divided by square root of 1 minus 0.2. It is as simple as that. Now you can apply the things here and just start calculating it. N to the power minus, what should come here? EDR is 0.01. N to the power minus 1, 0.01 plus square root of rho is square root of 0.2 into n minus n to the power minus 1, 99.5 comes here. 99.5. So it should be given as 0.995, right? 0.995 should be given here. Then in the denominator you get square root of 1 minus 0.2, that is 0.8. Square root of 0.8 you get here. I will do the WCDRTX. Sumudhu has done the WCDR, the value there, 9.59. Yes, we will check. I think I really appreciate Subudhu's work. Yes, arrived at the WCDR. Now, after arriving at WCDR, we will have to do something else also. Anyway, others also should try to get that value. We will see whether he is correct. Uresha, have you started doing it?
Yes, sir,
Right.
I'm checking the in value, the last
Okay,
one.
okay, okay. Now, this is the Vashisek model. WCDR Tx is equal to n to the power minus 1 EDR plus square root of rho into n to the power minus x divided by 1 minus rho square root. So we need to apply the values n n minus 1 of EDR is 0.01 plus square root of 0.2 into n minus 0.995 divided by 1 minus rho is 1 minus 0.2, that is 0.8, square root of 0.8. So we will see what it is. Now you need to go through the normal curve tables and get the n minus 0.1 value and n minus 0.995 value. We will see what value is. N minus 0.1 is 0.01. 0. 2.326.
Sir,
Yeah,
on the question, this row value is 2, no?
yeah. Point two.
Ah,
Point two.
okay.
Oh. Ah. Ah. Oh. 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 Come on. Come on. Oh. Come on. Oh. Oh. Dekat anu tu. Kawan ya, ikan ya itu. Kawan ya, kawan. Tunai lah hari dah hari dah. Right. I think there are possibilities of getting the answer. Sumudhu has he got the answer. Actually, I think the early answer is better. Is 9. It is closer to the correct answer. Correct answer is 9.56. 9.56 is the correct answer. Sumudhu, your early answer is correct. More correct than this one. It is 9.56. Like. One, 3. Yeah. Do it. Right. I think Sumudhu is correct actually. Sumudhu's second answer is correct. More correct. It should be 9.45 or something. In my opinion, in my calculations, it comes as 9.445. Because your n value comes as minus 1.313. I don't know. You also got the same value. Sumudhu, what is your n value? What is the n value you got? Minus 1.313. 315 you got. Okay. There's no issue. I think you made some type of rounding off or whatever. Yes, it's okay. Because if you, I mean, for my figures, I got it as 9.45. Now, have you got the figures for n minus 1 EDR as minus 2.326 and n minus 0.995 as 2.575? Those are the figures you should get. Now, others also have done it. Hiroshika, Uresha. Have you come to the answer, WCDR? Any issues, any questions? You can come up with your own issues, own problems. But even in these financial calculators, you don't find these normal curve figures in those calculators. That is the issue. So then for the normal curve type of things, still we need to go for these normal curve tables. So I will take the value as 9.45. Yes. Uresha, have you got the answer?
So I waited because I initially did with the not 0.22. So there, that when I was doing this V1,
You just put it as 2, but I
yes,
think the
yes,
correlation cannot be 2, no?
yeah, yeah. So the recalculation I did, but I don't get the number. I will check
Right,
it
right.
later.
Okay. I think you can just, you can just change that and do it again. So then I think it would be easier, no?
Yes,
Rather
that's
than-
why I started, but again, I'm not
Yes,
getting your answer. I'll check
right,
it
right.
later. Sir.
Okay, okay. What about the others? Hiroshika, have you started doing it or have you tried to do it?
Yes, sir, started.
Right, good. Because the problem now we have only done the first part of it because there are several other things to be done here. So the particular answer, the worst case probability of default as per my calculation is 9.45. 9.45. That is the calculation which I have made. .45%. This is the worst case default rate for the portfolio. Now, if you go to the sum again, you will find that the bank's total exposure is $10 million with this portfolio. And the recovery rate is also averages to 40%. So that means the loss given default is 60%. Then the 1 year credit, so that means we have just got the WCDR. So that is the worst case default rate. In a worst case situation, you will have this type of a loss. So now with the probability of default, you are in a position to calculate because the total exposure is 10 million. 10 million and 10 million into that is the exposure at default, and that has to be multiplied with 9.45%. And the LGD, what is LGD? Since it is for 1 year, so you can just have it that way. So then just do the calculation and get me the figure, because the total exposure is 10 million. Total exposure is 10 million. Worst case default rate we have calculated is 9.4645. And the loss given default also we can get from the sum itself. So then get the value, the VAR or the value at risk. Yes, Sumudhu, correct. Your answer is correct. 0.5567, yes. So that means $567,000 would be the worst case loss or the VAR. So we call it value at risk. You can say at a 99.5% confidence, your credit loss would not be higher than 567. It is not 560. Yes, 0.567 million is $567,000. So as a portfolio, I think it may not be a big amount in case of a worst case. So this is a type of process what we do in order to have a stress testing. Because the stress testing is a quantification of stresses. Now I just want to ask you another question here. Now this estimation is taken for a 99.5% confidence level. Now if I ask you to do it for 99.9% confidence level, what would happen? What would happen? If I ask to do a calculation for a VAR at a confidence level of 99.9%. Can you give an idea about the VAR, the value of VAR? Would it be higher or would it be lower? Yes. Would it be lower or higher? Now I think you all should understand what we are doing here. What we are doing here is we have gone through a 10 million portfolio of loans. That is, the total value is $10 million. And we have determined the EDR, expected default rate of that portfolio for each and every loan. It is taken as 1%. And Copula correlation also being taken as 0.2. And we calculated the worst case default rate at a confidence level of 99.5%. And we found that value as $567,000. Right? So then, can you give me an idea? If I ask you to do the value at risk calculation or the worst case calculation at a confidence level of 99.9%. What would happen? That is my question. So you need to say whether you get a higher figure or lower figure. It's a simple question. Lower or higher?
It's higher.
It should be a higher figure, yes. Yes, Anjali. It should be a higher figure. So why do we say that? Because when you want to have a worst case rate at a confidence level of a higher confidence level, so then invariably the reported loss would be higher. Right. So if we want, you can just have a trial on that. Say you can just get X as 0.999 and do the calculation, and you will see that the loss amount will go higher, or the WCDR will be higher. Or the other way, if you take it as 99% rather than 99.5, there you will see a lower figure for the loss amount. Even if you put it for 90, then the figures would be very much lower. But if you want to have a higher stress level, you need to go for higher confidence levels. This 99.5 is the regulatory confidence level normally. Regulatory confidence level. Now, in time to time, sometimes the regulations could be changed. The Basel committee also might decide on the confidence level sometimes. I think, do you have any idea about this confidence level also? What is the idea you have on this? No, what you normally do is, now the value at risk calculation is also something like this. Because you go for a particular level where you can say you are pretty sure that your loss would not go beyond this. That is what you say. Because you are 99.5% confident your loss would not go beyond $567,000 for this portfolio. So that's the type of a stress quantification. So that is, I think, fair enough. I think we have gone through 99.5% confidence level. And if you put it 99.9%, then you will have a higher figure. Right. Now I think we can have another situation checked through this same model. Now say, with the economic conditions, deterioration of economic conditions, you will arrive, or you will find a situation where the correlation has become 0.5. rather than 0.2. And you need to check it at a 99.9% confidence level. 99.9% confidence level. Then you have to check the worst case default rate and at the same time, so I will put it as a question here, so then we can work it out. So I will put that question on the left hand side. Right. Now I am just referring to the same portfolio, but with the economic downturn, what happens was, with an economic downturn, if the correlation becomes 0.5 and EDR becomes 5%, calculate the credit VAR at 99% confidence. Now this time I have just bring down marginally the confidence level to 99%. Assume the recovery rate as 20%. Now earlier the recovery rate was 40%. No, this time the recovery rate is only 20%. So with that you do the calculations again. Got it now? All of you do the calculation again and see what will happen there. Now this is a new situation where economy has a downturn. As a result, the EDR has gone up from 1% to 5%. Even the recovery rate has come down from 40% to 20%. And we need to calculate the VAR at a confidence level of 99%, not 99.5%, or 99% we need to calculate. Just check what would be the VAR or the loss at a 99% confidence level. So we will do that now. Now all of you should try to do that now. Now anyway, if you are not done the question here, I will give you the answers. The answer for worst case default rate is 9.45 for this question. Actually, we have already done it. And you got the loss or the credit VAR as $567,000 for the portfolio. Right? Now I have given you a new situation where the expected default rate has gone up to 5% with an economic downturn, and recovery rate has come down to 20%. But we need to, this time we need to have this worst case calculation to be done at a 99% confidence level. So just do it now. So I think you got my point, huh? Now, Sumudhu, what you have you got the n value for that? What is the n value you got? Now you need to replace EDR with 0.05, no? And correlation will have a 0.5, square root of 0.5 into 990, 0.990 you get there. Yes, Sumudhu, what did you get as n? What is the n value you got?
I think so I have calculated it for 99.9%. It should be 99.
Yeah, that's a good.
99%. That's the case.
Yeah. No, I think even if you calculate it for 99%, I think there's a small problem because you might not get a real n value. That is the issue. So that's what I am really worried. Now you calculated it for 99.9%.
99.9%.
Right. Okay.
That may be the reason.
Right. Uresha, have you tried that? Have you
So
attempted?
I tried, so I got this 0.6838, then I arrived at 0.484 as the n value.
Point?
484.
0.48.
480.
N is 0.48.
Yeah.
If it is 0.48, so then what is the value you got as the WCDR?
That is, it has to be multiplied. Sorry, the WCDR is 0.48. N value should.
0.48 means 48%, is it? 48%, is it?
Yeah.
Right. It might happen that way. And what is the n value you got for that?
So that is 0.6836, no? From that,
6836. Ah, yeah. Right. Okay.
I'm not sure whether I'm correct.
0.68. 0.68. If it is 0.68, your probability would not be that, no? 68. If it is 0.68, if I put it that way, it is 75.17 or something, no? We go into the tables.
6836 in the table, it's there. 668.
You are referring 0.68, no? 0.68.
Yeah.
So then 0.6, if you get the 0.6 row, there you have
68439.
yeah, 68. There you get 0.7517 if you go for 68. Just to go for 68 and see what it is. That is 75.17, is it? 0.7517 comes, no? Yeah.
Yes, sir. 75.175.
Yeah. That comes. That comes if you go for 0.68. But I think you have a little different figure, no?
Yes, sir.
0.68 something. Okay, I think it may be correct. But I had a little issue because I didn't get that value also because I made a mistake somewhere, I think. Okay. Right, anyway, now you will find that the WCDR is exponentially higher for this. Earlier you can see our WCDR came as 9.45, whereas now you might get about more than 70%. So that means it's a drastic and exponential increase of WCDR. And you will see the loss also. If you calculate it for that value, you will get the loss also at a very high rate. So just calculate the loss also for the new conditions. As per the new conditions, your LGD is 80% rather than 60% last time.
If we applied by 0.75, it comes to 0.60.
What is
10
that?
into 0.75 into 0.8.
Yeah, correct. So what is the value there then? 10 into 0.7
5175
0.75, yes.
to 0.8.
0.75 into 0.8.
0.60.
6. Then you will get the value of 6 million, no? Is it?
Yeah.
6 million, yes. 6 million you get. 6 million is a drastic loss. The drastic loss because you have only the portfolio is 10 million. You are losing 6 million from that portfolio. So that's a drastic loss. 60% loss you have altogether. So that is also a situation where you can expect. Now we can just review it again and see what really happened there. Now I have given you the correlation. Earlier the correlation was only 0.2. This time it has gone up to 0.5. So the 0.5 correlation is a significant correlation. 0.5. So then that is that way. It has not even gone beyond that. Then I just told you the EDR also has gone up 5-fold because it was earlier at 1%. This time it has gone up to 5%. So then not only that, then I told you the loss given default also been increased. Now earlier the recovery rate was given as 40%. So therefore at that time the LGD was 60%. But this time the loss given, the recovery rate is only 20%. Then the loss given default is 80%. 80%. Then when you calculate the WCDR, when you got it as 70 point something, 75 or something, then you can say 0.75 into 10 into 0.8. Then you get the value as 6 million as the loss. That is the credit value at risk. Now you can see as a percentage, the value at risk is the value is 60% of the portfolio value. So that's a drastic loss. Drastic loss. Last time you can see what is the percentage there. Now out of 10 million, you lose only 567,000. It is 1/20th. 1/20th, like, no, 1/20th. That only 5% loss. Now this time you will have a loss of 60%. I don't know those figures. You have any idea? Now just look at the total portfolio value, that is 10 million. No? At the earlier situation, your worst case loss was 567,000. If you take the portfolio as a whole, it is about 5% from the total portfolio. Do you agree with me? The total portfolio is 10 million, no? Whereas the loss is only 0.567 million. So that's approximately 5% of the total portfolio. So the worst case loss is only 5% of the total portfolio. Worst case, right? But this time, what is the worst case loss? It is 6 million. Now 6 million is 60% of the portfolio. The worst case loss will become 60% of the portfolio. So earlier it was only 5%. Now there's the loss percentage increased by 12-fold. 12-fold increase. But you can see what is the increase of probability of default? It's only 5-fold increase. And as a probability of default, 5% is not a big amount. But at the same time, the correlation also been increased from 2 to 0.2 to 0.5. But that is also not be taken as a big increase if you take remotely, only that. But now you have seen how the loss, worst case loss, has gone up, exponentially gone up. Now those things you need to understand. Rather than these calculations, what matters is that. Any question on this? Any question on this? Any question on this? Now in expected loss and unexpected loss format, what is the relevance here? Now when you calculate the worst case default rate, you are going for the unexpected part of it. But there's an expected part of it also. But when you go to this, you will cover the expected part already. So then your excess amount, so that is what you call the economic capital. I think that theory you need to understand. Now when you calculate the worst case default rate, you will find a loss. So that loss is already unexpected loss. But when you calculate the expected loss, what will happen? We calculate on the normal probability of default. A normal loss given default. So that is what you call the expected loss. But your unexpected loss is the total amount. And if you want to get the economic capital level calculated, what do you mean by economic capital? Economic capital is the capital which can absorb unexpected loss. So then, if you take the total loss as certain amount, say, now here we have a loss of 6 million. No? But if you go to the expected loss level, what is that? What is the expected loss here? Portfolio's expected loss. I am referring to the second situation. At the second situation, the loss given default has been increased to 80%. So if you go to the expected loss calculations, you will get 10 into 0.8 into 10 into 0.8 into 0.05, is it? So that is only 0.4. So that is $400,000. 0.4. 0.4. You can say $400,000, right? So that is the expected loss. That is the expected loss. But our unexpected loss we got as 6 million, is it? Then the economic capital would be 6 million minus 400,000. So that is 5.6 million, is it? Yeah, that's 5.6 million is the economic capital. I don't know whether you got my point. Resha, are you okay with that?
Yes, sir. So basically,
I am referring to economic capital. Now, when you say, if you want to calculate the economic capital is the portion of capital where it can absorb the unexpected loss. Now, for expected loss, we have the normal capital. For to cover the unexpected loss, we need to have economic capital. Now, in this particular case, you can calculate the expected loss of the portfolio. It comes to, I will give the multiplication. Now, the probability of EDR is 5%. EDR is 5%. Exposure is 10%. So 10 into 0.05 into 0.8. So that gives you the expected loss of that portfolio. That comes to 400,000 or 0.4 million. Then if you go to worst case default rate, now that comes to 70 something. So there, when you calculate that, you get the worst case loss as 6 million. But in order to get the capital, economic capital calculated, you have to deduct the expected loss from that. So then the total unexpected loss is 6 million. But out of which, worst case loss, we call it worst case loss, 6 million, out of which expected is 400,000, that is 0.4. So then the economic capital would be 6 minus 0.4, that is 5.6 million. That would be the economic capital. That would be the economic capital. I think, is that clear? Is that clear? Now I just can refer you the slides explanation also here. Now just look at it. Now here it is taken. Now when you use the WCDR and do the multiplication, you get the unexpected loss or worst case loss.
So
Now,
in practical scenario with this economic capital, what sort of decisions we can get?
pardon?
In the practical scenario with
Yeah.
this economic capital value, what sort of decisions we can get?
Yeah, it's like this. Now, when you calculate the regulatory capital, right? So you can see the regulatory capital is basically used to absorb the normal losses, expected losses. But and at the same time, as per the regulations, there are several imposements where the bank has to go through, and they have to have capital for those things. But when you say economic capital, now that capital is the capital where you can use for any unexpected situations, extraordinary situations. So now the calculation of economic capital is, it's like this. Now, for example, now the banks will have to maintain a capital adequacy of, say, 13.5%. So that is the regulatory capital you need to maintain. Now, if a bank maintains a capital adequacy of, say, 15%, now they have a margin of 1.5% capital margin. That 1.5% capital margin is the economic capital they have. You got my point?
Okay, so is it the same one now? The central bank has issued different because previous it was the flat rate for development banks and the commercial.
Yeah.
Now, okay.
Yeah, I think they have some type of relevance with that principle, and that is why they ask for these capital conservation buffers and all sort of things.
Yeah. Now the different banks have different ratios. No?
Yeah, that's the thing.
Central banks.
That's the thing. Yeah, because these economic capital can be different for different types of organizations, because that depends on the organization's risk profile. So because of that, it can happen that way. Now, the unexpected loss is also been calculated on that basis. So I think now the things are really arranged in that way, because I think even the people in banks also now understood what the central bank means by these things. As it is, if you have a capital which is higher than your regulatory requirement and you have a comfortable margin, it shows that the bank is in a strong position, a sustainable position, because now that is the amount where you can use for or utilize for highly unexpected situations. All other situations being covered through the regulatory capital. You got my point? So it's like this. Now say, though you do not have a big margin, but your intention, the bank's intention is to somehow get that margin increased. So if you are in a process of increasing that margin, then you are in a trajectory of sustainability. Is that clear? Because you always should see what would be our unexpected loss and see whether we have enough capital to deal with that. That is why we do this type of stress testing. I think that matter might have some fair meaning, no? Is it? What do you say, Uresha?
Yes, sir. Because anyhow now the Basel compliances are being imposed, and I think the central bank is like going forward with the amalgamation on other banks also if they
Yeah,
can't.
yeah, of course. Yes, yes, yes. And I think for a bank, these calculations and these stress testings are very much helpful, because they can plan forward with those things. And if they find any type of deficiency in their portfolios or in their normal credit management or whatever, they have ample time to correct those things. And that can become an early warning signal for them, and they would be in a position to correct themselves in a timely manner. That is the expectation of these things. So anything else you need to clarify? I think you should ask questions, and you should ask the relevance of these things to the real life situations. Just putting theory into these things would not help. But if you should know the meaning of this. You should know the fundamentals of these things. And at the same time, what I want to tell you is, I have seen most of the banks now purchased several software packages for credit risk management, in addition to their rating models. So therefore, you need to have this type of knowledge, even to deal with such type of software packages. Otherwise, what would happen is, you would get a certain package which would not be valid, which would not be suitable for your use. Just a package. But if you have the knowledge, if you have the principles understood, then you are in a position to see whether your package really serves a purpose for your bank. Got my message there? So you have to be careful then. And it's a very good service for your organization to look at these things and have a proper idea about your software packages. So the other thing is, those people, the vendors, they would not be in a position to hoodwink you if you know the stuff. So I think what I suggest is, you can go through these presentations again, the theory parts again, and get a good idea about these things. Because my intention is to give you a certain exposure where you can improve and add value to your normal job situations, or add value to your activities. By doing that, you will become trained or suitable credit analyst in your organization, and not only for the Sri Lankan conditions, but for even international conditions. If you can deal with such type of things, you would have the competency to go out of the country and serve in other countries, and you will become an exchange earner for the country. Even I have something in my mind. I need to have a set of people who have been trained to tackle any type of financial job internationally. If we can develop such type of a team, such type of a crowd of people, they would be in a position to gain employment from other countries, and that would become an exchange earner for the country. So I think you all should have this idea in your mind. You should become highly competent financial analyst or financial people, and then you will be in a position to take any responsibility from any international company, international organization, and serve for those organizations and get foreign exchange to the country. So I think with that idea, I think I just wind up today's session. So I
Sir,
think
before winding up, can I ask a question on
Yeah.
our this assignment?
Yeah.
There we do have to, like in our example in the tutorial, we have to do this cash flow at risk, but when we are doing our assignment, we have to take example. So,
Yeah, of course, yes.
so we have to apply this cash flow at risk also and
Yeah.
include in the module. So.
Yeah, because then only it would be completed. Otherwise, it is half half done. That's the thing.
Right.
So
So
because
this is the
yeah.
probability part we have, because we don't have any standard model to be used.
Yeah, of course, it's okay, but only thing is this cash flow at risk or whatever it is. Now you can just go by the normal cash flow situations and normal indicators. That would be okay.
Right. So
Right. Anything else you need to clarify?
I'm fine. So thank you.
Right. With that, I wind up the session today, and thank you very much for all of your involvement in the lesson, and you have really participated in the lesson very diligently, and I think you all can come to a higher level in competency of these things. And my wish is also that you all should try to do that. And if you need any type of any resources or whatever it is, any new knowledge or whatever, you just tell me, and I will try my best to do it. Thank you very much.